Let's start with the MAC address, which stands for Media Access Control Address. Every network device, whether it's your laptop, smartphone, or even your Wi-Fi router, has a unique MAC address embedded in its network interface card. Think of it as a hardware fingerprint for your device, usually 48 bits long and displayed in hexadecimal format like 00, 1A, 2B, 3C, 4D, 5E. The MAC address operates at layer 2 of the OSI model, the data link layer, and is crucial for identifying devices within a local network. For example, when two laptops are connected to the same Wi-Fi, the router uses their MAC addresses to decide which device receives which data, ensuring smooth and secure communication within your home or office network. Moving on, let's talk about frames and packets, two essential data units in networking. A frame is the data unit at the data link layer, containing source and destination MAC addresses, error checking information, and the actual data packet inside. Frames are used for transferring data within the same local network or subnet. On the other hand, a packet is the data unit at the network layer, which includes source and destination IP addresses, port numbers, and the payload. Packets are designed for communication across larger networks like the internet. For instance, when you access a website from your laptop, your data travels as a packet all the way to the web server. Frames handle local delivery while packets manage broader communication. Now let's dive into subnetting and supernetting, two techniques that help manage and organize networks efficiently. Subnetting involves dividing a large IP network into smaller logical segments called subnets. This makes routing more efficient, enhances security, and limits unnecessary broadcast traffic. For example, a 192.168.10.24 subnet can have up to 256 unique IP addresses. Supernetting, also known as CIDR aggregation, is the opposite. It merges multiple smaller subnets into a larger network. This helps reduce the size of routing tables and streamlines network management. For instance, combining 192.168.00.24 through 192.168.30.24 creates a single 192.168.00.22 supernet, making things simpler for network administrators. Finally, let's understand sockets, which are crucial for network communication. A socket is simply a combination of an IP address and a port number, creating a unique endpoint for data exchange. For example, 192.168.110.80 represents an HTTP web server, while 192.168.110.443 could be the same device running an HTTPS service. Sockets allow multiple services to run on the same device without interfering with each other, making network communication organized and efficient. Whenever you browse the web, stream videos, or send emails, sockets are working behind the scenes to ensure your data reaches the right destination securely and reliably. Wrap up, let's quickly summarize the key concepts layer by layer. The MAC address is your device's unique hardware ID at layer 2, the data link layer. Frames are the data units used within local networks, also at layer 2. Packets operate at layer 3, the network layer, and are essential for internet communication. Subnets help divide large networks into manageable parts, while supernets merge smaller networks for efficiency. Finally, sockets combine IP addresses and port numbers to create unique communication endpoints. Understanding these basics is essential for anyone interested in networking, as they form the foundation of how devices connect and communicate in the digital world.